Welcome to video number 5 for chapter 2, in which we look at significant figures in calculations. Why do we need to worry about sig figs in calculations? First of all, scientific calculations involve measurements that have communicated uncertainty, which is given by their significant figures. The calculated result cannot be more precise than the least precise input value, and we have to learn how to determine the number of significant figures for the result and then round that result to the appropriate number of digits. Rounding to significant figures is just like rounding in your math class, except we have to know how many significant figures we have. We're going to start with the largest non-zero digit. That's the most significant digit. Starting there, we're going to count to the right the number of significant digits that we want. Look at the digit following that last significant digit. If it is less than 5, then we're going to drop that digit and everything following it. Call that rounding down. If the next digit is greater than 5, round the last significant digit up 1 and drop everything following it. We're going to call that rounding up. Also, the size of the number must stay the same. If the number is less than 1, then we're going to keep all leading zeros for magnitude. That's all the zeros that come after the decimal point and before the first non-zero digit. If the number is greater than 1 and you have removed any digits above the ones place, this is going to be important if you don't have a decimal point, then you must replace those digits with a 0 to keep the magnitude. You cannot change the magnitude of the number, and we'll see how this works when we get to some examples. All right. Finally, if you are unable to have the correct number of zeros for your significant figures, you must put the number in scientific notation. All right, let's look at some examples then. First, though, I will show you how to do the first one. In this first one, we want to round to 3 significant figures. The 7 is our first non-zero digit, so it's our first and largest significant digit. We want 3 significant digits, so this 7 is significant, and this 0 would also be considered significant. Beyond the 0 is a 6. This 6 is going to round the 0 up to a 1. That's going to be the last of our significant digits, and so we're going to have 77.1. And don't forget, we've got to keep those units there. Grams is what we want to have there. Alright, so I'm going to pause the video at this point. There's a 77.1 grams. I want you to round these numbers to the correct number of significant digits. And we're back. So, how did you do on this? In this first, the second example really, our significant digits, the 6 is our first significant digit, 3 and 0 are all significant. This number 0 here is not greater than 5, so we round down. Now we're going to say that we drop these all, which would give us 6, 3, and then we have to pad 0, 0, 0, 0, 0, because that 6 still has to read 6 million. However, to our significant figure rules, that only has 2 significant figures. We want 3. To make this 0 significant, we need to convert this to scientific notation, as we saw in a previous video, and so this becomes 6.30 times 10 to the 6th centimeters cubed. Don't forget that unit. In this example, the 2 is our first significant digit, the 3 and the 3 are both significant. The 5 is going to round that 3 up to a 4, and we're going to drop it right there. There's our 3 significant figures. 102,030. Here's our first significant digit. The largest one is always first, second, and third. There's a 0 here, so we don't do anything to that 2. Now we're going to drop these, but because we're dropping them, we need to pad 0, 0, 0 after that. Otherwise, the 102,000 becomes some other number. And we have 3 significant figures. Remember, by our rules, these zeros here are magnitude zeros. 2895 times 10 to the 21st kilometers. The 5 rounds the 9 up. The 9 is our third significant digit. Because the 9 gets rounded up to a 0, that's going to round the 8 up again and make a 9 0. That 0 is significant, 2.90 times 10 to the 21st kilometers. And we have a similar sort of situation here. 3 significant figures, 7, the 5, the 9 is significant. This 9 rounds this 9 up, but it rounds it up to a 0. That means the 9 is going to round the 5 up to a 6, 760. To have 3 significant figures, we can either put that decimal point here, as I've shown you right here, or you can convert to scientific notation. It never is wrong, as long as the scientific notation is correct, never wrong to use scientific notation. Alright, so let's take a look at determining the correct number of significant figures to round a calculation to. There are 2 sets of rules. The first one, in multiplication and division, the result has to have the same number of significant figures as the input with the least number of significant figures. This is really just a way of saying that the result can be no more precise than the least precise number used to calculate it. Okay, we're going to perform the following calculations together. And remember, in multiplication or division, units can be multiplied or divided. And we'll see how that works. Here we have 4.32 millimeters times 1.7 millimeters. This would be like we're taking an area. We have a length times a width. Alright, so as our input numbers, when we first multiply them, we get 7.344 millimeters squared. Millimeters times millimeters gives us millimeters squared. But let's take a look at our input numbers. We have 3 significant figures here. We have 2 significant figures here. So our result must be rounded to 2 significant figures. There's 1, there's 2. That's as far out as we can go for rounding. The 4 doesn't round the 3 up. And so to round to 2 significant figures, we get 7.3 millimeters squared. Let's do a division. We're taking 38.742 grams, dividing it by 0.421 grams. This is a ratio. In this ratio, grams divided by grams, the units are going to cancel. Be careful with that. When we do the math, we get 92.0238. In our inputs, we have 5 significant digits here. We only have 3 significant digits here, so we're going to round to 3 significant figures. 92.0. Don't forget our units. No units. 92.0 is 3 significant figures. Third example, we're going to do another multiplication. This would be like a length times the width times the height, so this would be a volume perhaps. When we do the math, we get 32.4319 meters times meters times meters is meters cubed. We have 3 significant figures here. We have 3 significant figures here. We have 4 significant figures here. So between the first 2 numbers, we have to limit ourselves to 3 significant figures. 1, 2, 3. The 3 does not round the 4 up, so drop everything after that. And we get 32.4 meters cubed. 3 significant figures. You notice when I did these calculations, I did the calculations first and then I rounded. People often worry that they're throwing away important information. You're not throwing away important information. What you're saying is that you're showing the last digit that you have any knowledge of. If we have 3 significant figures here and 3 significant figures here, then that means that this can only be known to 3 significant figures. Alright, it is your turn. I want you to perform the following multiplications and divisions. I want you to indicate, in all cases, the raw answer. That's your calculation before you round it. I want you to indicate how many significant figures there are, and I want you to round your answer to the correct significant figures. I'll pause the video, let you do your work, and then you can restart the video when you're ready. Alright, so you're back. How did you do? 89.5540 times 43.10 centimeters times centimeters is going to be centimeters squared. We'll worry about that in our units. In our first number, we have 6 significant digits. 1, 2, 3, 4, 5. That 0 is significant. In our second number, we have 4 significant digits. Again, that 0 is significant. So we're going to round this to 4 significant figures. The 7 rounds the 9 up. The 9, rounding up, rounds the 5 up. We have 4 significant figures, and we're going to round this to 3860 with that decimal point, centimeters squared. You could also have said 3.860 times 10 to the third centimeters squared. In our second number, we have another division. This is like taking an area and dividing it by the length to find the width. The result tells us this long number here, but we notice in our input numbers we have 3 significant figures. This 0 is not significant. 1, 2, 3 significant figures. This number has 4 significant figures, so we're going to round to 3 significant figures. The 6 rounds the 9 up. 9 rounding up rounds the 3 up. 3 significant figures. We get 7.40 meters. Meters squared divided by meters gives us meters. In the third example, we're taking a mass. It has 4 significant figures. We're dividing it by a count. This is a count. Specs is something you can count. We do the math. The significant figures are only going to be given by the grams, so we have 4 significant figures. In this case, when we round, the 3 does not round the 9 up, so we round to 2.109. Don't forget to bring across the 10 to the minus 4. And the units, grams divided by specs, is grams per spec. That's an awful lot like grams per milliliter or grams per cubic centimeter in a density. In this last example, we have 278.4 millimeters squared times 25.2 millimeters. This is like an area times a height to give us a volume. When we do the math, we get 7015.68. We have 4 significant figures here. We have 3 significant figures here. So that means we only can report this to 3 significant figures. The 5 rounds the 1 up. Because we're throwing away this 5, don't forget to pad that with a 0. 3 significant figures. We round this to 7020 millimeters cubed. Remember, this is a volume now, and this is our 3 significant figures. This is just a magnitude 0 to make sure that we read this as 7020. With addition and subtraction, there's a different set of rules. In addition and subtraction, the first thing you have to note is that in order to add and subtract numbers, you must have the same units. For example, this makes no sense whatsoever. 85.1 grams plus 91.8 kilometers makes absolutely no sense. So we're never going to see something like this. The result is always going to be rounded to the decimal place of the input number with the least precise decimal place. So for example, when we add these 3 numbers, this number goes to the 1,000th, this number goes to the 10th, and this number goes to the 100th spot. So this number, the 2.8, has the least precise decimal. That's where we're going to round to. It's often helpful to see addition and subtraction in columnar form. So let's take a look at how this works. Let's put together our 3 numbers, 11.234 grams. Notice all the units are the same, 2.8 grams, 9.57 grams. In order to know how to round, we find that number with the least precise ending. And let's draw a line right down there indicating that's as far out as our result can go. Since that's going to be where we round to, the 23.6 is going to be our answer. 23.6 grams, that 0 and 4 get dropped. Let's do another example. Now we're going to add 7532 meters and 400 meters. Where is the least precise decimal place in this? Well, in this case, because these zeros are just magnitude zeros, this is our least precise number, and the hundreds place, the hundreds place is where we have to round this to. So draw our line there. We do the math first. As before, we always do the math first. Then we round. Now, we're rounding to the 79, but remember, when we drop these, we have to pad that with zeros to keep the magnitude the same. There's our two significant figures now, where we've rounded to the hundreds place. These are now our magnitude zeros. Alright, now it's your turn. As before, I'm going to have you perform some practice additions and subtractions. In this case, I want you to indicate where that last significant digit is according to your input numbers. Then I want you to use column addition and subtraction, and finally round your answer. Don't forget to have the correct units there. I'll pause the video, start it up again when you are ready. Alright, let's see how we did. In this first number, first addition, the 5.3 tells us our last significant digit, so that's the 10th place. If we add them up in their column form, then we draw that line down behind the 10th place. That means we're going to round this. The 8 rounds the 0 up to a 1. We drop everything off after that, and it's 91.1 centimeters. In the second example, we have the hundredths place for both of our numbers. We put the columnar form together. Let's put that line there. Now that line is going to show us that when we subtract, that 0 at the end is going to be significant. There's no rounding, so 3.40 milliliters is our answer. Finally, in this last number, the ones place is the last place that we have in this first number. So that's going to be our farthest place out that we can go. We put the column form together, draw that line down behind the ones place. That'll show us that we have to round this number to the ones place. The 6 rounds the 0 up to a 1, and we get 251 meters. Sometimes you're going to have combined calculations, for example, with our percent error. So, when you have a combined calculation, the first thing you're going to do is determine the Sig Figs by the order of calculations. Do the first calculation first, find its number of significant figures, round, and then keep going. So, for when we're doing the percent error, the first thing we're going to do is we're going to do our calculation of the subtraction in the numerator. When we do that subtraction, 8.42, this is an example that we used earlier in this video series, minus 8.92 grams per cubic centimeter, gives us a value of 0.50 grams per cubic centimeter. You notice this is subtraction, so we're going to the hundredth spot. Going to the hundredth spot. Not 3 significant figures, but we're going to the hundredth spot. Now, when we take that and plug that into the next part of the calculation, we're going to divide by the 8.92 grams per cubic centimeter, and we're going to multiply by 100. So in multiplication and division, we look at significant figures. So this value now has 2 significant figures. The 5 and the 0 are significant. 2 significant figures, 3 significant figures. This 100, that's an exact number. So that's going to be an infinite number of significant figures. Because we have 2 in here, we can only report 2 significant figures in our result. Let's give you a chance to try this. We're going to take a sample of palladium with a mass of 39.07 grams, and the student is going to put it into 5.35 milliliters of water in a graduated cylinder, 10 milliliters, and she's going to record the final volume as 8.6 milliliters. I want you to calculate the density here by water displacement. So remember, find the volume of the metal first, and then use that in the density equation to find the density. Keep track of your significant figures as you go. Good luck. And we're back. So how did you do? First, we're going to determine the volume of the water, of the metal by water displacement. Now, when we do the math, we get 8.6 minus 5.35 is equal to 3.25 milliliters. But did you notice that this final volume only goes out to the 10th spot. So we have to round this to the 10th spot. The 5 rounds a 2 up, and we get a volume of 3.3 milliliters, which, if you remember correctly, for solids is the same as cubic centimeters. So we're going to use the cubic centimeters, that's okay, in the density part of the equation. Next, we're going to use the volume of the metal. In the density equation, we bring down the mass. Now this is a division. Here's the mass, here's the volume. The mass is to 4 significant figures. The volume is only to 2 significant figures. So when we round our answer, even though this is what we get in our calculator, we can only round to 2 significant figures. The 8 rounds the 1 up to a 2, and our answer is reported as 12 cubic centimeters. As I said, this is division, so the result is precise only to 2 significant figures. If the student had recorded the final volume as probably would have been appropriate to a third to the 100th spot, then we would have been able to record this to 3 significant figures. This would have been to the 100th spot. This would have been 3 significant figures, and we would have gotten 1 more significant figure out of this. So, cautionary tale, please make sure you read all equipment to their maximum number of significant figures. Alright, so we'll see you in class tomorrow to work on this material. If you have any questions, please go back and review the video.